Hello students, welcome. This technically begins Notes Chapter 17. It's what I call Chapter 17. It was taken out of a textbook that we currently use but refer to sometimes within the classroom dealing with substitute teachers. As well, occasionally we'll use questions out of this book, but there's only a classroom set of these for you to use within class, and so that's why we call it Chapter 17. The particles that make up all matter, of course, are called atoms. Properties or characteristics of matter are examples like color, odor, shape, texture, hardness, mass, weight, volume, and density. Okay, mass by definition is the amount of matter in an object. The mass of an object is constant. It does not change unless some matter is either added to the object or removed from the object. It simply just does not change, from location to location. I'm going to have the same amount of matter whether or not I'm here in Pleasantville, Iowa, or I go to Los Angeles, California. Same amount of matter. Weight, of course, by definition, is the response of mass to the pull of gravity. Your weight can change from place to place. As we go up higher into space, we actually start noticing that our weight decreases because the pull of gravity is not as strong on us as it is here on the surface of the Earth. And eventually we can get out into space and we become what we call weightless. Specific gravity is the comparison of the density of an object to the density of water. Now, for instance, the specific gravity for water is 1. Remember that, it's 1 for water. Okay, physical properties again are color, shape, hardness, texture, weight, volume, density. All of these are examples of physical properties. Physical properties are those that can be observed without changing the identity of the substance. Example is, wood is still wood whether or not it's in the form of a baseball bat or you have it in the form of chips, wood chips. Still wood. Phases are states of matter. The first one, of course, is a solid. A solid has a definite shape and a definite volume. And there's also vibrations within that solid. For instance, the desk or wherever the table that you're currently taking these notes on, actually, if we could go down to the subatomic level, has vibrations in it. There's actually movement. In many solids, the particles are arranged in regular repeating patterns called crystals. Solids that lose their shape under certain conditions are called amorphous solids, spelled A-M-O-R-P-H-O-U-S, amorphous solids. These are examples like tar, wax, glass, especially old window glass. And if you actually notice it, it's actually thicker at the bottom of the window glass than it is at the top. It's kind of wavy in it. Liquids have no definite shape but a definite volume. They take the shape of their container. Viscosity is the resistance of a liquid to flow. Think about honey, for instance, in a jar. It still flows, but it doesn't like to flow. Okay, gas does not have a definite shape or a definite volume. Matter is anything that has mass and takes up space. And there's different types of matter. For instance, homogeneous matter, all parts of matter are alike. Example is sugar. Is sugar clear through, the sugar bowl? Salt, water, whipped cream. It's all the same. Heterogeneous matter is all parts of this matter are not alike. Example, soil, super cheeseburger, yum. Granite, granite tabletops or countertops. Cereal with raisins. This is heterogeneous matter. Okay, a mixture is matter that consists of two or more substances mixed together but not chemically combined. Substances in a mixture are not chemically combined. They keep their separate identities and most of their properties. They can be separated into similar parts through differences in physical properties. Example is sugar and water are mixed. The water is still a colorless liquid. The sugar still keeps its property of sweetness. And then, of course, if we wanted to separate those two, we could simply just evaporate the water from the sugar mixture, and then we would have sugar left in the container. There are two types of mixtures. Again, it is a heterogeneous mixture. The particles are large enough to be seen and to separate from the mixture. Concrete, Raisin Bran, Super Supreme Pizza, cookie dough, chocolate chip cookie dough, these are all things that you can actually see the particles, you can actually pluck them out, they're large enough to be seen. Homogeneous mixtures, our particles are very small and do not settle when the mixture is allowed to stand. So in other words, we can't see the particles, and given time, they won't actually separate. And we'll give you some examples here in just a minute. A solution is a type of homogeneous mixture. It's a homogeneous mixture formed when one substance dissolves in another. For instance, ocean water, lemonade, tea. These are examples of a solution. A solution of tea, a solution of lemonade. Solutions have two important properties. Number one, the particles are not large enough to be seen. They're not large enough to be seen. Number two, the particles are evenly spread out. In other words, all parts of the solution are identical. Not all solutions are liquids. They can be solid, liquid, or gas. Metal solutions are called alloys. Gold jewelry, for instance, is an alloy of brass and gold. Sterling silver is an alloy of silver and copper. All matter is either a pure substance or a mixture. Pure substances are made of only one kind of material, and they have definite properties. They are either elements or compounds. Remember that. Elements and compounds are pure substances. For instance, iron, aluminum, water, sugar, table salt, oxygen, all of these things are examples of pure substances. Elements are the simplest pure substances. An element cannot be changed into simpler substances by heating or by any chemical process. Compounds are two or more elements that are chemically combined. A colloid is a heterogeneous mixture that, like a solution, never settles. Okay, it's like a solution, it never settles. One way to tell if a substance is a colloid from a solution is to pass a light through the substance. If the particles scatter light, it is a colloid. Example is called smoke. For instance, a smoky room, for instance, has the ability to scatter light. Also think about fog. When your headlights hit the fog, it has a tendency to scatter light, makes it difficult for us to be able to drive. The scattering of the light by particles in a mixture is called the Tyndall effect. It is called the Tyndall effect, T-Y-N-D-A-L, Tyndall effect. Okay, a suspension is a heterogeneous mixture containing a liquid in which visible particles can be seen, and they also scatter light. River water, etc., pond water, all of that stuff. If you went out to the Des Moines River and scooped up a bunch of pond or river water, you would notice that after time it would be able to settle out. That is a suspension. A suspension. Okay, physical properties are those that can be observed without changing the identity of the substance. Example, mass, weight, volume, density, color, shape, hardness, texture, smell. Example is odor. Chemical properties describe how a substance changes into another new substance. There's a term called flammability. Flammability is a chemical property that is the ability to burn. For instance, we take hydrogen plus oxygen will form water. The ability to support burning is another chemical bonding. Corrosion is an example of another chemical property. Will it corrode turn into rust, or maybe get some type of tarnishment, to tarnish on it, like our silver, our pure silver will. A physical change is a change in which physical properties of a substance are altered, but the substance remains the same kind of matter. Example is a tree trunk is sawed to wood chips. Shredded paper still is paper, still is wood. Chemical change, the changes that substances undergo when they change into a new and different substance. Okay, the law of conservation of mass. According to this law, the mass of all substances present before a chemical change equals the mass of all the substances remaining after the change. Distillation is the process of separating substances in a mixture by evaporating them. Okay, that includes chapter, I think it's 17, chapter 17 note sheet. Anyway, we will continue on in class with a discussion over this information, and thank you for being patient and tolerant of me.